Hi, here's the simulator, the Peter Higginson simulator, which is really neat. You can test your program. So let me describe it a little bit. I think you can push the help button over here, which will give you some documentation which explains the whole thing. And notice this is called the little man computer, and I have been referring to this as a little robot computer. Don't want to ascribe any human intelligence to the robot itself. So when you see LMC has been the traditional name for this, but at any rate, let me explain some of these things. First of all, here's the accumulator. You see this, and then that's the old A register in our drawing. You should have your drawing with you, by the way. And this is the program counter. Now, remember the fetch, decode, and execute cycle. When the robot fetches an instruction from the mailbox, one of the mailboxes here, it takes the instruction and puts it in here, and the address then over here. And anything that has to do with arithmetic, the simulator has built this thing called an arithmetic unit, so you can add and subtract. And it's also used to increase the program counter by 1. Here's the input, and here's the output. You'll see how it works. So let's put in the program that we had, and it's 901. And here we stored it in 390. We had another input, 901. And then we were going to add, which is 190. And then we were going to output 902. And that was it. So now let's run it and see what happens. So we start to run, and you can see all sorts of things happening. Well, let's reset, and let's run it step at a time. So we've reset here, and we still have our program in. Okay, and we'll now take the first step. Okay, what has happened is that the system went to the program counter, which was initially set at 0. It then said, okay, go to the 0 area, which had 901, brought the 901 in, and the 9 and then the 01 is here. It always splits it this way. And it went, and actually at the same time, it went to the arithmetic unit so we could add 1 to the program counter. Okay, now notice down here it says input required. Okay, let's put in our number. We used 32 as I remember, and push return. And now we're ready for, or did I push the return? Yes, there we go. Okay, so what happens is it immediately put that into the accumulator. That's what 901 does. Okay, now we're ready for next step. The next step, here we're going to look for number 1, comes back with that command, splits it for the decoding operation, and this is 390, and it took whatever was in here and it stuck it in 90, which is what you expected. At the same time, it went to the arithmetic unit to add 1 to the CPU. Okay, next step. Goes to 901 again. And it comes here, decodes it, and it asks for input. You can see it here. Okay, so let's put in the 5 as I remembered. We put in 5 before. And now the 5 goes in here. So the accumulator, the A register, now holds 5, and we're ready for the next step. Next step, it's going to go to 3, which is up here, and it's in red. You can see it. Ready for decoding. 190 it does. And it says add what's in 90 to the accumulator. Remember, it had 32, now it has 37. And notice, this number is still the same. So nothing gets destroyed unless it has to, where if you're replacing something. All right, we need one more step. And this step now, and that last step was 902, came in, took what was in the accumulator and put it in the output right here. So we've got the output here. Notice that the input wasn't even destroyed. It just took a copy. Now, are we finished? Not really, because remember, this is a robot in there. It has no brains. Well, it has a brain, but not like you and I think about it. Okay, now the last thing is it's going to go look for what's in number 5. There's 0 there. Now, generally, when you write a program, you have to put a halt in or a 0 somehow. But since everything is initialized to 0, that's automatically done. And it comes back, and now we're finished. It says program halted. We are finished. We still have our output out here. We still have this. And notice that the CPU, the program counter has been increased by 1 because that's part of the process. So we are finished. And now what I would suggest to do is go to get a copy of this simulator and do this yourself, because you can put these numbers in and then run the program and see if it works. If it doesn't, believe me, it will tell you something crazy will happen and you'll have to do a reset. It also, you might want to look at help. And if you want to look at some fancy programs, here are a whole bunch of programs. There's an add and add subtract, there's a find a maximum and so forth, and one's a bubble sort. So you can do some, even with this very simple structure, you can do some pretty complicated things. So take a good look at this simulator, and you can just sort of keep it in background and use it to check out any of your programs. And there's a big part over here called assembly language, which we will get into later. And then you write the program in assembler, and it will then translate it into these numbers and load them into the memory.